All right, what we have here is a graph of position versus time for a ball that rolls down a table. Starts at position x not equal 0, rolls down until you get a value for, or you get position x. And as you know, velocity is a change in position over the change in time, which is equal to the slope. This right here is equal to the slope of the graph. And if we look at the graph, we can see that the slope is constantly increasing with time. In fact, we learned earlier that if we take the slope of the tangent at any one point, then that tells us the velocity at a given time. So for example, if I turn the tangent feature on and I find the tangent of the line at this one that is tangent to this one point, the slope is 0.0832 meters per second, which tells us the velocity, which is called the instantaneous velocity, is equal to that slope at that point. Over here, we can see that the tangent increases in slope. So at this point right here, the slope of the tangent line to that point is 0.19 meters per second, which tells us the instantaneous velocity is equal to that at that point. And over here, we can see that the slope is even steeper. The slope here is 0.36, which tells us the velocity at this point is 0.36. So as this graph, as the time increases, we can see the slope increases, which tells the velocity increases, which is consistent with the marble rolling down the table. Our goal here is to find a graph of velocity versus time. And to do that, what we're going to do is we're going to enter the velocities on this table over here. We're going to go ahead and insert a column, add manual column. We'll call that velocity, which is meters per second. And go ahead and apply that. And sometimes it doesn't work. I'm not sure why. I'm going to try it again. I'm just going to say add manual column. Oh, it worked that time. How about that? I'm going to go column options. I'm going to go ahead and type in velocity, meters per second, apply. And now what I'm going to do is I'm going to find the velocities, all these instantaneous velocities I just spoke about, and put them in this data table. So for example, at 0.33 seconds, the velocity is 0.08. We're going to avoid the data points at the end. The computer does not have enough data to get an accurate tangent at the slope of the tangents at the end. So we're going to avoid the end points. At 0.67 seconds, the slope looks like 0.11. At 1 second, the slope is 0.13. At 1.33 seconds, the slope is 0.16. At 1.67, the slope is 0.19. At 2 seconds, the slope is 0.22. At 2.34 seconds, the slope is 0.24. At 2.67 seconds, the slope is 0.27. At 3 seconds, the slope is 0.3. At 3.34 seconds, the slope is 0.32. At 3.67 seconds, the slope is 0.34. And last but not least, at 4 seconds, the slope is 0.36. So at 4 seconds, this ball is traveling at 0.36 meters per second. So what we're going to do is we're going to go ahead and graph this this data now. Get rid of those diagrams. I want to turn this off right here. I want to look at that velocity graph I just created. Velocity graph. And you can see that, it looks pretty linear right there. In fact, we can go ahead and get a curve fit for that. I'm going to apply linear curve fit. Apply, and it looks like it's a pretty good fit. Regression is 0.999. Pretty good. So what we have here is we have a graph that we can now find the model for. So this is an equation of a line. The y-axis is velocity. The slope here looks like 0.08. The rise is meters per second. The run is seconds. And the x-axis is actually time. And our y-intercept is pretty darn small. I'm going to go ahead and ignore it for this situation. So it looks like that right there is our model for velocity. And this is something that we definitely need to talk about and figure out what that slope actually means. All right. So that's how you find a velocity graph. You start with the position graph, which we got from the video, and we find all of the go ahead and find the slope of all the tangents to each of the points. We go ahead and graph it, and from that we can get a velocity graph. From the velocity graph, we can go ahead and get a model. All right. Hey, good luck. Physics.